Hey guys, so today we're going to learn about dihybrid Punnett squares. So what exactly is a dihybrid Punnett square? A dihybrid is a Punnett square that basically crosses two traits from two organisms at the same time. This can be used instead of doing a Punnett square to look at eye color in rabbits and doing a separate one that looks at fur. A dihybrid would enable you to cross both traits from both parents in a single Punnett square. And of course, this can be used on any two organisms with any two traits. So here we have a dihybrid cross. We have one parent who is heterozygous for his blue eyes and his fur, while parent 2 is homozygous recessive for her red eyes and no fur. Let's figure out what the possible genotypes would be if they were crossed. And in this case, brown eyes are dominant, blue eyes are recessive, fur is dominant, and no fur is recessive. So, for the purpose of a dihybrid, let's imagine that the alleles that make up a genotype are like clothes. Just go with me on this. So let's say you have two shirts and two pairs of pants. How many different outfits can you make? Well, you could pair each shirt with a different pair of pants. So by doing this, you now end up with 4 different outfits, each shirt pairing with each kinds of pants. So each rabbit in this case has 4 alleles. Rabbit 1 is capital B, lowercase b, capital F, lowercase f, and rabbit 2 is lowercase b, lowercase f, lowercase f. Now let's look at the alleles for parent 1. Remember, he had capital B, lowercase b, capital F, lowercase f. Let's say that the first 2 alleles of a parent for a trait are the shirts and the second 2 alleles are the pants. So let's make the outfits. First, we're going to pair each shirt with a pair of pants. And in this case, the first 2 letters are the shirts. So we first start with capital B, pairing it with capital F, and pairing it with lowercase f. Now, we do the same thing here with our second shirt, which is the lowercase b. Lowercase b pairing with capital F, lowercase b pairing with lowercase f. So now, let's look at the outfits we created. For parent 1, he had capital B, lowercase b, capital F, lowercase f. And from that, we made capital B, capital F, capital B, lowercase f, lowercase b, capital F, and lowercase b, lowercase f. Parent 2 is easy. They only had all lowercase letters, so all of their outfits are going to look the exact same. Lowercase b, lowercase f. So, why go through the trouble of making outfits? Well, we made the outfits by using the different alleles and showing the different ways that they can combine. So, the different egg cells and sperm cells that can be created with those traits. So, once we've done that, we're now placing those traits on the outside perimeter of our Punnett square. Remember, parent 1, or the male, goes at the top, and parent 2, or the female, goes along the side. So, outside of each box, you should now have 2 letters, a shirt and a pant. So now that we got where the alleles go, now let's fill in our information into our Punnett square. We follow the same rules. We take Dad's information and bring it down into our Punnett square first, just like the arrow to the right tells us. Now, here we brought all of Dad's information down into our Punnett square. Now you might notice that the spacing might seem a little bit different, and that's based on the 2 letters that you brought down for Dad. Remember, if it's a capital letter, it's automatically going to be at the front of the box. However, when you're looking at things in a dihybrid, they always have to be written in the same way that the parent's original genotype was written. So the parent's original genotype had a capital B and a lowercase b together, followed by the pairs of capital F's and lowercase f's. So you need to make sure you leave enough space so that your final product can be written in the correct order. Next up, we have Mom's information. We're going to bring her information across into our Punnett square, just like our red arrow tells us. Remember, we've got to make sure that when we're writing them inside the box, we keep the B's grouped together and the F's grouped together. So that's why the spacing was important when you filled in Dad's information. So now we have our entire Punnett square filled in with Mom's information. And you'll notice that Mom's letters are in red. so that you can see where exactly they were placed. And remember, placement matters. The B's have to be grouped, the F's have to be grouped. And not only are they grouped together, if there is a capital in that situation, the capital letter has to come before the lowercase form of that letter. Now that we have our Punnett square complete, let's pull out our genotypes. Here, we list the letter combinations that we see. The entire first column are all the same. So they are capital B, lowercase b, capital F, lowercase f, and there's 4 of them. Continuing on, second column is the same situation, only this time we have 4 capital B, lowercase b, lowercase f, lowercase f. Continuing on, third column, 4 lowercase b, capital F, lowercase f. And our fourth and final column, 4 lowercase b, lowercase f, lowercase f. Now it's important to remember that not always are you going to end up with the 4 to 4 to 4 to 4 ratio or 1 to 1 to 1. But in this case, it worked out that way. Now from those genotypes, let's make the phenotypes. So our first one had capital B and a capital F. Well, capital B stood for brown eyes and capital F stood for fur. So those first 4 are going to be brown eyes with fur. Now, the next 4 have a capital B, but they only have 2 lowercase f's. So the capital B stands for brown eyes, but since it has the recessive form of the F trait there, that means it has no fur. So there'd be 4 brown eyes with no fur. So in our next one, we have the lowercase form of the trait to start out with, 2 lowercase b's, which means that this rabbit's going to have blue eyes. Also, it has a capital form of the fur trait, meaning that it's going to have fur. So 4 blue eyes with fur. And our fourth and final phenotype, 4 lowercase b, lowercase f, and it has the entire recessive form of all the traits. So it's going to be 4 with blue eyes and no fur. Congratulations, we did it!